last time. So last time we talked about strings, and we talked about sort of how we can go into greater detail with the strings and what we can do with them. I'm also going to open up the chat window here so I can see it. So if people have questions, whatever, I can see it from there. Whoop. Excellent. All right. You can also use the Q&A if you want. So basically, we were talking about strings. We were talking about how we can do a whole lot of things with strings. And one of the big important things you can do is retrieve information from a string. You can retrieve it via any integer. So if I say s equals A, B, C, D, F, G, H, I, J, right? So I can say the length of s is 10. Okay, that makes sense. There are 10 letters in there, 10 characters in there. But I can say s of like 5, and this gets or returns the item at index 5. Which we as humans would call the 6th letter, that's F, right? It's really important to remember that everything is zero-based. The indexing is zero-based in Python and many, many other languages as well. So the first question was that I wanted you to ask the user to enter the name and assign that to a variable called name. Then ask the user to enter an integer. Let me just copy and paste this, actually. That's probably the easiest, best thing to do. Oh, except that, of course, right, it's not formatted so well. Okay, and assign that to a variable called name. Then we're going to ask the user to enter an integer, and we're going to assign that to a variable called index. And we can assume that that's a legal index there, a legal number. And then what we're going to do is print the letter at that index. So really what I want to do is get to the point where I have my string. We're going to call it name. Oh, you can't hear. Let me make sure my mic is on. My mic seems to be on, so check your check your earphones. So what I want to do is get to the point where I have a variable name, which has a string. I have a variable index, which has a number, and I can print it out. In fact, watch what I can do here. I can say name equals s, and index equals 5. Then I can say name of index. And sure enough, that'll work just fine. Because what's really happening when I do this? Name refers to a string. So Python says, hey, name, what do you refer to? And it sort of follows that arrow, follows that pointer, we might call it in another language, and finds a string there. It says, hey, string, do you know what to do if I give you square brackets? The string is like, yeah, I do. So Python says, okay, well, if you're good at square brackets, then find the thing at index. And at that point, Python says, wait a second, index, that's a variable. I have to get the value associated with that. So it follows the arrow that index is pointing to something else, referring to something else, and it finds an integer. So if we have a string there in name and we have an integer in index, that all is good. So how can we get to that point where I'm going to say here name equals input, enter your name. And sure enough, input is a function that returns a string. We're going to then store that string inside of name. And great, we're doing great. And then I'm going to say index equals input, enter an index. And here, here I was evil and tricky. Because now if I try to say print name of index, it's going to blow up. How do I know? I know these things. Watch what happens. If I say Reuven and I say 3, index 3, it's going to be REUV, right? Because it's 0, 1, 2, 3, REUV. So it should return a V. But in fact, it's going to give me an error message. It's going to say, hey, you can't do that. Well, what did I do wrong here? It's going to say string indices must be integers. I'm like, yeah, I gave it 3, right? Because if I look at name, what is name? Name is the string Reuven. Very good. And if I look at index, what is index? Index is, it's the string 3. And here we once again see that the distinction between data types is really, really important in Python and in programming in general. And we can try as much as we want to convince Python that this 3 should be an integer, it should treat 3 as an integer. It won't. So what do we have to do? Well, one easy solution is I can say here, index equals int of index. Actually, no, I'm just going to copy this and put it in a new place so you can follow along and see like old things and new things. So I can say here, index equals int of index. And what's happening? Well, always in assignment, the right side executes before the left side. So the right side, I'm creating a new integer based on the string called index. I get a new integer. And then what do? I stick it into the variable index. So we could call this almost, almost kinda, right, transforming index from str to int. It's not really happening because what we're doing is we're creating a new integer based on the string, and then we're assigning it to index. But this is the way we can think about it. And so now if I say name is Reuven and the index is 3, it works fantastically. I can even be super fancy. And I can use an F string here, and I can say index in string name is, and I can say here name of index. See how I do that? Because the F string allows me to put in these curly braces whatever expressions I want. And here, the first expression is index, has to be an integer, but it gets turned into a string here. String name, well, strings are strings, that's fine. And here I'm actually executing the expression name index. And so I'm grabbing it there. So that was the first thing. Questions about this so far? I'll just like copy the second thing. All right, no questions so far. Fantastic. Either that or you all have to learn to type faster. Ha, okay. So let's see. So now I'm going to say modify the above code so that you can check. Oh, wait. Oh, what is an F string? Oh, sorry. Good question. So an F string in the end is a string. At the end of the day, an F string returns the value as a string, but it has these like special properties that if you put a lowercase f before the opening quote, it can be either single quotes or double quotes as usual in Python, but if you put a single f before the opening quote, then anytime you have curly braces inside of the string, those curly braces are replaced by their values. Here, let me give you like one or two examples here. So if I say x equals 10, I can say print of f, x is x. So far, so good, right? Because what happened here, we get the string back, x is, but the curly braces are replaced by 10. But I can even say here, like printf of x is x, but x times 2 is x times 2. And notice what we get back. Here we get the string, right? But it has x is 10, but x times 2 is 20. And so you could put all sorts of expressions there. And F strings are relatively new in Python. They're like 3 years old or so. And they've been around since Python 3.6, and they make it so easy to create strings that combine different data types. Because normally if you try to use like a plus between the strings, that's fine, but plus between a string and integer will blow up on you. All right, so hopefully that explained it. And you can go really, really deep with F strings if you want. There's all sorts of crazy stuff that they can do. So now we want to modify the above code, and we want to check whether index is legal. And if the user enters a negative number, or a positive number that's too high, then scold them. Otherwise, print the letter that index. So I'm going to copy the code we already have. Right? Always good to start with working code. Always good to start with something that someone else did, so I don't need to worry about it. So here, index equals end of index. Great. So the error that we're going to get, if we get an error, is going to be down here in 12. So we need to put some code between line 9 and line 12 to check. So what am I going to do? Well, first, the easy part. I can say here, if index is less than 0, print too low. Right? The minimum is 0. And I can say here, else print. So this code will work. And this will make sure that it'll give it a negative index. Let's try this. I'm going to say here, name is Ruben, and index is -5. And it's too low, the minimum is 0. In fact, let's even put in here, let's say index is too low. It's like, tell them what the problem is. So if I say here, Ruben, oh, it doesn't matter, -5. -5 is too low, the minimum is 0. By the way, this, I would say, is a great example of how you can make your error messages better. Tell the user what they entered that was bad. Don't just say, you did something wrong, right? Something was too low, something was too high. Say what was too low, say what the value was. I'll give you an example. So you all used my online course system. I use this system, this company called Podia, to sell my online courses, including the free courses like this one. And Podia is generally amazing, really, really, really amazing. I love them. I've been working with them for about 2.5 years now. I have very few complaints, but when I have complaints, they're very specific. So yesterday I created like a new course, just like play around with their platform a little bit. And then I wanted to delete it. Now I have a long list of courses. And when I clicked on delete, it said, are you sure you want to delete that course? It didn't say which one it was. And I was petrified that I was going to accidentally delete a course that I was actually interested in keeping. So I actually canceled it and tried it again. And then I sent them a note saying you should really do that. So saying what value was wrong, what value is going to be deleted, always a good idea. So far, so good. But this is not doing everything we wanted. We also want to make sure if it's not too high. Well, what would too high be? Well, let's see, name. Name is there. And the len of name is 6 because there's 6 letters there. So what if I say name of square bracket 6? Is that not, is this too high or is this okay? And the answer is this is actually too high. Because if you use the same number as you had in len starts counting with 1. And why is that? That seems kind of weird, right? Like, why would the length of a string be 1 more? Well, think of it. The len of the empty string, right? Empty string, length is 0. And len of a, right? String with index, a character at index 0, length is 1. So this is where you can get this famous off by 1 error, because we as humans are used to counting starting at 1, and here the computer is starting at 0, is the index 0, is the length 0, it's kind of confusing. So what I have to do here is say, hey, is this too high? But I can't say, like what I'm tempted to do is say something like, let's just paste this down here. I can say here, elif index is greater than len of name. Print, and let's just copy this, make it a little appropriate, right? But we can say here, index is too high. The maximum is, and then I can even say len of name. All great, but not, this won't work. So if I say here, Reuven, and I say 5, I get the n. So far, so good. But what if I say here, Reuven, and I say 6? It's going to blow up on me. Why is it going to blow up? Because I entered 6. 6 is not greater than the length of name. It is equal to the length of name. And this is where we run into all sorts of weird, frustrating, annoying bugs in programming. It's these edge cases of equal or greater than equal. So I want to say here, greater than or equal. If the index is greater than or equal to the length of name, then it's too high. And so I can even say the maximum is len of name minus 1. And so now if I say Reuven, I say give me index 6, it'll say, hey, 6 is too high, the maximum is 5. And if I say Reuven and I say 5, then we're doing great. But of course I can enter any string I want, right? You know, elephant, not a common name nowadays. And if I say like, 8 is too high, the maximum is 7. So we have here 0, 1, 2, 3, 4, 5, 6, 7. Sure enough, it's right. The computer speaks truth. And so what you're seeing already is we are starting to use and recombine these techniques we've seen again and again in new and interesting and useful ways. This is useful. So Jason asks, isn't the user always going to start indexing with 1, not 0? Oh, those users. They're such a wild bunch. Yeah. So this is where you might want to do some sort of translation from like user land into programming land, right? So you might want to say to the user, enter, like here I said enter an index, and we're assuming that our user is computer literate. I know, we're in fantasy land here. But basically, we are going to ask for an index here, and that index is very computerish. However, in a real program that was talking to real people who are not necessarily computer people, you might want to do something else. You might want to ask for a number and then translate it, like do a +1 or -1 as appropriate to get it from what they're thinking into what we would be using. And that is, again, a source of countless errors in the world of programming. Any other questions about this before we move on to the big one, Pig Latin? Okay. So what I want to do now is a Pig Latin translator. And this is one of my favorite exercises to give. It's not original with me. It's like a very common thing to do. And by the way, you might have heard, some of you older folks like me might be familiar with the Logo programming language. Right? This is a language designed for kids by Seymour Papert. Back in the early 1970s, believe it or not, he thought that children should learn to program. And that they could do it. And like computers at that time were these huge things, like took up half a room, and yet he was having kids use it. And so there's a great series called Computer Science Logo Style by Brian Harvey. Fantastic set of books, and that's where I learned to use Pig Latin as an example. And so fun set of books, and they really get into some deep ideas. So what's the basic idea in Pig Latin? So if the first letter is a vowel, that's A, E, I, O, or U, then add way. And otherwise, in all other cases, move the first letter to the end and add AY. Okay? So that's the basic idea here. That's how Pig Latin works. And like you can get into all sorts of little nuances of what happens if it's a single sound and 2 letters. We're not dealing with that. So how am I going to do this? Well, I'm going to say, first of all, word equals input, enter a word. Let's get the word from the user. So far, so good. And now, how do I check to see if the first letter is a vowel? And this is where, I'm telling you right now, I teach this all the time to experienced programmers. People who come from other languages come up with all sorts of crazy, interesting, complex ways of solving this problem. So I want to show them to you because they point to some common misconceptions and common errors. So the first way is you can say, well, if word equals a, or, oh, sorry, not word, word 0, we're checking the first letter, right? Word 0 equals a, or word 0 equals e, or word 0 equals I, or word 0 equals o, or word 0 equals u. Now, we did something like this last week, and it's super common to do this because, like, it makes sense. I want to check if it's this or this or this or this or this, and it will work. You can say here then print word plus way, and so this will work, right? We're going to ignore the other cases. So if I say here, once again, elephant, it's going to print elephant way, and if I run it and say octopus way, terrific. But surely there's a better way to do this. So what's one better way to do it? Well, people are often tempted to say, well, what if I do this? Or E, or I, or O. And I know I showed this to you last week, but like this is so important to understand that we'll even spend some more time on it. So here we're saying if word 0 is A or E or I, and at first it looks really great. Like we can say elephant, and it works great. And I say octopus, it works great. So what happens if I try something that does not start with a vowel? Let's do this. Let's say here, towel. Towel way, not good. So what's going on here? What is the problem here? The problem is that how we see it and how Python sees it are totally different. We see it as, oh, if word 0 is this or this or this or this or this. No, that's not how Python sees it. Python sees it as, if the first letter is A, okay, that could be true or false, or the string E. Every single string in a Boolean context is true. So what we're basically saying, like what this works out to be is if word 0 equals a, or true, or true, or true, or true. That's what Python sees. And so it's always going to be true. So you don't want to do that. But I'm going to tell you right now, and we did this a little bit in the forum, this is not the right way to search. This is not the right way to check. There's such an easier way, and it's like mind-blowing to see. If word 0 in A-E-I-O-U, meaning we use a string now, not as text, not as a name, not as something we're going to be like printing. We use it as a collection. We use it as something we're going to search inside of. And so sure enough, now what we're doing is we're saying if word 0 is in this string, and it's always, in is always going to be little in big, returns true or false. So if our first letter is in these letters, then print word plus way. And it's so much, like, I think more elegant and beautiful this way, but it's not obvious unless you see it first. And I tell you this after see this for a lot of years. Okay, fine. So that's like how we can check to see if the first letter is a vowel. But what if it's not a vowel? Else, what do we do in all other cases? Well, I said that I want to move the first letter to the end and then add a Y. How do we move a letter? Well, that's a little bit of a trick phrasing there because you can't change a string in Python. Strings are immutable. Once they're set, they are set forever. So we're going to have to create a new string based on the original string. So let's say I say here, word is this, word is towel. So how can I move the first letter to the end? Well, I'm going to need a little trickery. I'm going to first take everything but the first letter. So everything but the first letter plus first letter. How can we do that? Well, I could say word 1 colon to the end. This means this is a slice, right? This is a slice, everything from word starting with index 1. So that's great. And we get back owl. And then if I say word of 0, well, that's going to give me the first letter. So if I say word of 1 colon, and then plus word of 0, what do I get? That's right. I get word with the first letter moved to the end. Have I changed word? No, not at all. I've created a new string, which doesn't have a name even, it's just a string. So now we can go back and use this, and I can now say else print, and I'll say word of 1 colon plus word of 0 plus a Y. Now if I say towel, we get owl tay. And if I say papaya, I get apaya pay, and so forth. And sure enough, we now have a fully functional Pig Latin translator. Not bad for like 4 lines of code, eh? Questions or comments about this? And then we'll start talking about methods. Okay, I see. Oh, some of the Q&A. Oh, memory will be, oh, excellent question, excellent question. Yes. So memory will be allocated for this newly allocated created string. So in many like low-level languages, or I should say especially like C and C++, especially in C, if you want to create a new string, if you want to have like stuff, you need to manage its memory. You need to say to the language, hey language, I need some memory. Do you have enough memory for me? And the language says yes, or the language says no. And then after you've allocated the memory, then you have to use the memory and then you free it up. That's nuts. Like, I can't believe people still do this nowadays. Basically, something known as garbage collection has been around for 50, 60 years already in the programming world, and Python uses that. So does Java, so does C#, sort of more modern languages. And the idea is that when you create a string, the memory is automatically allocated, and when you don't need the string anymore, the memory is freed up and returned to the operating system. You do not need to worry about memory. You need to worry sometimes about how much memory you're using, but that's like making sure your program's optimized. That's not a like allocating and so forth. Oh, and Randy asks, why show a papaya? Oh, so here's the thing. So I just like to use papaya because it's like a fun word. So papaya, papaya. Does it start with a vowel? No. So starts with a non-vowel, let's say. So what are we going to do? We're going to take all but the first letter. So that's going to be here, papaya. And then we're going to put the first letter at the end. So that's going to be P. And then we're going to say, put that together and add a Y. And it's going to be then papaya plus P plus a Y. And sure enough, if I do that there, actually, let's just like break off this cell here. And if I run this, what do I get? Oh, I have to put this in a comment. That's where we get that from. This is effectively what was being created and put together when we did that. Okay, any other questions about this stuff? All right, and if we do, like, feel free to put it in the chat. So what I want to talk to you now about is something called methods. And this is actually we can get very, very, very deep into this. Some of you might have heard of something known as object-oriented programming. Sometimes people like to call it OOP. I don't know. I think I've actually found it's mostly in non-native English-speaking countries that people talk about it as OOP. I can't explain why. And we are not going to talk about object-oriented programming in this class. Like, it's too advanced. We're not going to get into it all. But this is where like we can't avoid it to some degree at least. And the idea is, if I have a string, so s equals a, b, c, d, e, and I run len on the string, so I'm running a function, len, on data, s. So you can think of it as, I've also, another way to think about it is I'm, applying a verb to a noun. So we get len of s, and we get back a value. So far, so good. But this means we sort of have a whole bunch of functions like len, like input, like print, floating around in memory. And we have a whole bunch of data like s and like name and like word floating around in memory. And we have to remember which data and which functions go together. So for example, what if I try to get the length of 11? We're going to do len of 11. We're going to get an error. And it's going to say, wait a second, integers don't have lengths. What does that even mean? This is an inappropriate function to call on an integer. It's perfectly fine on a string or many other types. You can't get the length of an integer. That just does not work. So in the 1970s, believe it or not, right, in the 1970s, late 1970s and 1980s, people invented object-oriented programming. It was especially at Xerox PARC, a Palo Alto Research Center, where they invented a ton of things. They invented the graphical user interface. They invented the mouse. They invented the laser printer. They invented Ethernet. They invented PostScript, the language that's used in a lot of printers nowadays. They invented a ton of stuff. By the way, Xerox did not know how to market it or sell it whatsoever. And so the people who invented these things, many of them went off and started companies like Adobe and 3Com and so forth, and became billionaires. And Xerox, well, very smart people, but not doing so great in the computer department at least. Although I just read recently they're going to buy HP maybe. Crazy stuff, crazy world. In any event, one of the things they invented, so this guy named Alan Kay invented Smalltalk, a programming language. And he called it an object-oriented language. And the idea was, instead of verb, noun, we would say noun.verb. And you might say, who cares? Why is this possibly interesting? And the idea is that the verbs are then attached to the nouns. You don't have the verbs, the functions are sort of floating around. They are all attached to a certain kind of noun, and you can only use them in certain places. So like in that sort of syntax, and this does not work in Python, I would say like, 11.len, right? Doesn't work in Python. Or not good in Python. But the idea is there, that basically I would no longer be able to even make the mistake of calling len on something because it would not exist. It's not that it would give me an error. It would give me an error of not existing. Why am I telling you this? So Python actually is an object-oriented language at the core. It uses these things called objects. It allows us to organize our data and our functions and our functionality more easily. And many, many things in Python are written that way. So believe it or not, there are more methods than functions in Python. And for now, we can think of them as functions attached to our data. So really what this means is there are a ton of functions that we can, or I should say methods, that we can run on strings. We're not going to review all of them, but what we're going to start doing now is looking at some of these methods, and you're going to see there are methods for strings, there are methods for lists, there are methods for dictionaries, and you're going to find that as you sort of progress in your programming career, one of the key questions you're going to ask yourself and others, and documentation when you look at it, is okay, I'm learning about a new object, a new type of data. What methods does it support? What can I actually use? And so it's going to be useful to sort of look into that and figure that out. So let me give you an example, and we're going to see a bunch of examples now. So one example, so let's say this. Let's say I do name equals input, enter your name. I'm going to say here print hello name. Seems pretty innocuous, right? And sure enough, if I say here, enter your name Reuven, I enter it, hello Reuven. Very nice. Okay. But what if I do something a little different? What if, I'm a little tired and I fall asleep on the keyboard? And I wake up and I write my name and I fall asleep on the keyboard again. And I wake up and I press enter. Oh my God, what happened here? What's the value of name, for crying out loud? I say name, and we see that the string reflects exactly what the user entered. This is the string. And notice, space characters are characters. Like Python's not going to ignore space characters just because it looks stupid. As far as the programming language is concerned, this is what the user entered. This is what their name must be. So how can we deal with this? Well, it turns out the strip method returns a new string without the surrounding white space. That means spaces, new lines, etc. So if I now say name.strip, what this means is return a string based on name. And sure enough, look what I get back. I get back the string Reuven without the white space on the outside. What has happened to name? Nothing at all. The string name, the variable name, continues to contain that white space. The original name is unchanged. Why? Because strings are immutable. They can never be changed in Python. So we haven't changed it, but we did get back a new string. Now we can do a sneaky trick. I can say here, pretend that name has changed. In this way, name equals name.strip. And now what are we doing? We are creating a new string, name.strip, and then we're saying, by the way, Python, I want name to refer to name.strip. And now after we've done that, well, now name doesn't have that white space on the outside. So this is an example of a method. There is no strip method for integers. There is no strip method for true and false. Strip is bound tightly. It is connected to strings, but any string can use the strip method. Now, strip, like many, many methods, can take arguments, optional things, and on. There are all sorts of additional functionality you can run them. But for now, this actually works pretty well, and this is kind of useful. Okay, questions until here. So the new name overrides the previous one. Yes. So what I did here was I said, hey Python, because whenever you have assignment, the right side executes, gets you a value, and that value is assigned to the left-hand side. So in this case, I ran name.strip, I got back a new string value, and then I stuck that new string value into name, rendering the old name unfindable. There's no way to get to it, and in fact, it's probably been removed from memory altogether. Okay. Any other questions people might have about this? Okay, keep the questions coming if you have. So what other methods do we have, and how can I know what methods there are? So I'll show you like a cheap way to know what methods there are and a smarter way to know what methods there are. So in Jupyter, you can sort of complete any name with the tab key. So if I say name dot, so name is a string. If name is a string and I say name dot and I press tab, look at this. Hello, where's this? It's a little slow today. Let's try this again. It's like stealing my thunder here. Name dot. What the heck? All right, well, normally it would give me a little menu there showing me what's, oh, there we go, there we go. It's a little sleepy. Oh, here we go. VXP just asked, if name equals what, name one equals name two, I change name two. Oh, great question, great question. So let me just address that. So if I say name one, so if I do like, you know, S1 equals ABCD, and then S2 equals S1. So what does this mean? This means S1 is ABCD, and then S2 and S1 are now referring to exactly the same thing, S1, S2. But then I say S1 equals EFGH. So what is S2? Let's find out. It is still ABCD, because here I didn't say that S2 is going to follow S1 around. It's not like going to keep going wherever. It's not saying like, you know, this does not mean where, you know, whatever S1 contains in the future, S2 will contain. No, that's not what it means. It means right now whatever S1 has. So if we change S1 down the line, yeah, we talked about this last week. This is a really important point. Okay, back to our little menu. So name dot. So look at the menu here I have, and we'll look at a bunch of these methods here. So if you ever are like, what is this method called? It's good to say name dot, and you get this little thing. And most editors, most like debuggers and so forth, will also give you access to this sort of thing. So no matter what you're working with in Python, you will usually have this kind of access. And we'll talk about a few other methods in just a moment. So what if I say now, I'm going to go to python.org, and this is the main Python website. And if I go here to documentation, and we'll go to the Python 3 documentation, I'm going to put the final link I get to in just a moment. All right, and I go to the library reference. The Python standard library is like it's the list of all the things that come with Python. And I scroll down a little bit, and we'll get to strings, stir. I'm going to paste this into the chat so you can all look at it if you want. All right, so I'll put this in here. There we go. All right, this is all about strings. And look what it has here. It has a list string methods. Here, I'll even like paste a link directly to that. All right. Oh, I guess I did that already. Oh, I didn't expect. Oh, I guess fine. So in any event, what you have here is a list of all the methods, and then in many cases, not all, they will even give you examples. If it's like complex, they'll give you examples. You are not, repeat, not expected as a programmer to remember all of these things. It will not happen. You will remember many of them. You will have to look up many of them. And over time, you will get to know many of the common ones. But you can see there are many methods. And if every single data type has its own methods, that's a lot of methods to keep track of. So let's look at a few of them and see how we can use them in our work. So watch this. Let's say I'm going to run our Pig Latin program again. Here, let me get, grab that. Where was that here? Here we go. All right. All right. So I'm going to just do this down here. So you can see here that all is good. I'm just going to get rid of the comment so it's a little tighter. Okay. I'll even get rid of this comment here. All right. So now watch this. I'm going to run this. And I'm going to say, watch how sneaky I am. Apple. I'll even say apple with a capital A and lowercase everything else. What happened? Well, the computer did what we told it, which is look at the first letter. If the first letter is A-E-I-O-U, then add away. But wait a second. The first letter is an A, but it's a capital A. So Python did not see this as a match. So one quick and easy way to handle this is say like A-I-O-U, like that. But maybe the rest of the word should be lowercase as well. So it turns out that there are several methods for dealing with capitalization. If I say S equals A, B, C, D, E, F, G, H, I. If I say now S dot lower, so it returns a new string based on S, all in lowercase. And if I say S dot upper, it returns a new string based on S, all in capital letters. And if I say S dot capitalize, returns a new string based on S, first letter capitalized. Caps, rest, lower. And sure enough, I can say S dot capitalize, and you'll see what it did there. I can even do S dot swap case. Why anyone would ever want swap case is beyond me. However, it's been in Python for many years, so I don't know. Like, I'm sure it's useful for someone somewhere. In any event, you can see then that this gives us a great deal of power. What I can do now is I can say, well, I don't want to just get the word from the user. I can change this. I can say now, right? So let's make sure the user's word is all in lowercase letters. And so now I can say enter a word, and watch what I'm going to do. I'm going to say word equals word dot lower. And now if I say even like apple, it'll say apple way. Look, nice lowercase. And if I say banana, it'll say do the right thing. So because what has happened, I've taken the user's input and I've turned into a lowercase word. But I can do even better than this. I can say, watch this. This is going to be called method chaining. I can say dot lower. Now this is really cool because what I'm saying here is input, enter a word. What does input return? It returns a string. So we've got a string, but before we assign it to word, we're first going to run a method on it. What method are we going to run? We're going to run lower. And it's the result of lower that will be assigned into word. Not, so basically this string here is anonymous. And on this anonymous string, we'll run the method, then we'll assign that back to word. So now if I say like banana, prints out banana bay, right? And word is all lowercase. And as far as Python's concerned, word never saw a letter with uppercase letters in it. Okay, but what if I take this and now like, all is good. And then I've got a smart alecky user, because that's what they're like. And they enter space banana. Oh, that's not so good. What happened? Well, what happened is pretty clear, right? It took the first letter. It checked, is the first letter a vowel, A-E-I-O-U? The answer is no, it is not A-E-I-O-U. So we're going to take that first letter, we're going to put it at the end, and it doesn't know that the first letter is a space as opposed to a letter. So what if I were to use strip there? So I know I'm going to run strip. And then I can say banana, and then, oh, wait, we're back to the old problem. So here's what I'm going to do. Even more method chaining. I'm going to say input. Input gets something from the user, returns a string. On that string, we're going to run strip. What does that do? It returns a string. On that string, we're going to run lower. What are we going to do with that string? We're going to assign it back to word. And now I can say here, space, 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 banana, space, 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 all good. This is what programs do to make sure that their users don't mess up too much. When you log into a website with your email address, I guarantee you that if you put spaces before your email address, you'll still be able to log in. Why? It's comparing strings, right? It's comparing usernames. Well, because they are stripping, just like we do here, although whatever language they're using is doing it, they're stripping the white space from the beginning to the end to make sure you don't have this sort of problem. How do I know? Because I was one of the dumb people who many years ago, probably 15, 20 years ago, forgot to do that on a website I worked on. And oh boy, was there hell to pay. Okay. Questions or comments about this so far? All right. Oh, does K-swap always work by threes? Oh no, K-swap will do whatever you want. Like, I mean, it just makes lowercase, uppercase, and uppercase lowercase. So S equals A, B, C, D, E, F, G, H, H, I, J, K, L, M, N, or P. If I say S, K-swap Oh, what did I do here? Oh, swap case. Right, like, again, why does anyone possibly need this method? I'm not sure, but it survived for a long time, so it's there. Can we use the word capitalize? Well, yeah. Oh, yeah. Sure. Because word.capitalize returns a string, and so if it's returning a string, you can do any string things you want to it. So you say print, even like you say f string. Your word is word, and capitalized, it is capitalized. Right? That works just fine. Oh, it's probably because some people, I don't know, but they type in all caps, so use lower. I'm sure there is some like good historical reason for using it, but I cannot imagine what it is. Seems like, is there a limit to the number of items in the chain? No, but the more you chain methods together, the more you might run into the possibility that there's an error in the middle there, and then go try to debug it. So method chaining is great, but try to limit it. Like, unless if you're just doing stuff on strings, like stripping and lowercase, I think that's totally fine because you're not also changing things. But the moment you start like really messing around with stuff too much, try to keep it on separate lines. You know when caps is on you case change? Yeah, but then you can just do lower. Is lower. Yeah, VXP, you don't have to raise your hand. You can just like enter something in the chat. That's probably like the easiest thing. And while you're entering that, I'll just show you one or two other things. So let's go back to one of the first examples we saw today. So if I say here, like name equals, let's just do this, Ruben. I say here index equals 3, print name of index. So far, so good. But what if I say here, index equals the string 3? Oh, well, obviously what I want to do then is, index equals int of index, and then we'll be fine. Also fine and good. But what if I do this? What if I say index equals 3? Yeah, computers are smart. They should be able to figure that out, right? No, clearly not. Right? Int does not know what to do with this word 3. It can't turn that into an index. Why would this matter? Because let's say I'm no longer hard coding. I'm saying name equals input, enter your name. And then index equals input, enter an index. Well, if I do this, right? If I say here, Reuven and 3, we're doing great. But if I say here, Reuven and the word 3, bad news. So how can I protect against this? How can I check for it? Well, time to introduce you to another method. And that method is index.isDigit. And this returns true if index only contains 0 to 9. How is that possibly useful? Because then we can check, can I turn this into an int, right? So if isDigit returns true, the string is intable, as I like to say. It means that you can turn it into an integer, meaning I can do something like this. I can say here, if index is digit, then do this, oops, and that. Else print index is not an integer, add value. So if I say now Reuven and 3, all is good, because what happens? We get the value of name, we get the value of the index, we check, can we turn this index into an int? The answer is yes. In fact, I'm even going further. I'm going to say here dot strip. Let's get rid of a white space on either side. And then if we can turn it into an integer, then fantastic. We do that and we get back. But if I say here, oops, Reuven and, I don't know, dog. Dog is not an integer, bad value, bad dog. So suddenly we're discovering that with these methods, we can do all sorts of really sophisticated behavior. I can check the user's input. I can sort of change the user's input. And I can make sure that it's only going to actually get to the logic in my program, like the core logic there, if I really need. Oh, Larry asks, how do you strip white space between characters? Ah, okay, I see someone's been checking. So watch this. If you say here s equals space, oh, let's do this. Space is A, space is B, space is C. Oh, and I'll get to the question about isDigit in just a moment. All right, so if I say s.strip, look what I get back. Strip only removes the outer white space. So it'll remove the stuff before A, and it'll remove the stuff after C, but it won't change anything inside. What you can do, though, is you can use, oops, no, come back. Use strip.replace to replace a character in the string. So we can say here s.replace space with nothing. So replace spaces, empty string. And now look what we get back. We get back ABC. But have I changed S? No, we haven't changed S because that's right, strings are immutable. So if I say here S now, you'll see that it still has that. But if I were to say S equals S dot replace of space and empty string, then now we have indeed replaced all the spaces, not just the what's the beginning and end. So this is how, like, I constantly have to tell people, even like really experienced developers, that knowing how these data structures work and knowing their methods is key to efficient, good work in Python. You can just like do amazing stuff if you really know these methods well. There was a question before, right, from Krishnendu about is digit checks for integer or floats also? Only for integer. So if I have s equals 1, 2, 3, then s is digit, return true. And if I say s equals 1, 2, 3, 4, 5, 6, and then I can say s is digit, it'll say false. It's very sad this is true. I wish to check. Now there are some other methods. In fact, if I say s dot is tab, look at all the different methods I have. Is alnum, for like alphanumeric. So is it alnum? No, not even that. Because the moment that you have the decimal point in there, it won't. Is alpha, like is it alphabetical only? Is it ASCII? Is it a decimal number? Is digit? Is identifier? Is lower? Is numeric? Is printable? Even is numeric will not work. So, and like there are three that are very close. Is digit, is numeric, is decimal. It's not worth worrying right now about the details of that. If you want, I have a blog post about it somewhere about the differences between them. And it's really subtle. Most people don't care. Ibar is asking, going back to your earlier example, is there a method for turning the word 3 to the integer 3? The answer is yes, but you would need to program it. You need to have like a bunch of if statements, or like using what's known as a dictionary in what we would call a translation table, where you'd say, if it's this, then it's that. But there's no automatic programmatic way that I can think of offhand to do that sort of thing. But I like the idea. All right, let's try an exercise for a few minutes to sort of try out what we've talked about here, and then we'll go over together. And I think maybe I'll show you one or two other things, and we'll close up for the day. And then, of course, I'll put some questions probably tomorrow night or Sunday in the forum. So here's what I want you to do, and I'll paste this into the chat as well. So ask the user to enter two numbers. If either number, right, or if either input is not, numeric, not intable, then tell the user which of those values was not good, or both, right? And then if the values are interval, then let's say print their sum. All right, so I'll put this in the chat as well. I'll give you like 2-3 minutes to work on this, and I realize that that's not a lot of time to work on an exercise, so don't feel any pressure if you can't get to it. Meanwhile, while people are working on this, I'm just going to mute my mic, but if people have questions, feel free to post them in the chat or whatever. Oh, how do you bring up the help menu? Oh, help menu in Jupyter. So if you go, actually, I wonder if you go to the help menu. I've never actually used that. Keyboard shortcuts. Whoa, first time ever using that. So there you go. So if you go to the help menu, and you can get the keyboard shortcuts. If you're talking about the menu of like methods, if you do like s equals ABC and then s dot, that'll bring up a menu of methods available on a particular data structure. And you'll see there are all these methods that like we're not going to get to that you don't need to worry about. I'll show you one or two others after the exercise, but I do this all the time because I don't remember all the names for sure. Can I give you another like 2 minutes to sort of work on this? Again, if there are any questions, feel free to. I'm just going to mute my mic so you don't have to hear like clacking and tapping and so forth until then. Okay, let's go over this together. Again, if you didn't manage to do this in time, that's okay. All right, let me see. Why is this not? Oh, there we go. Come on. Okay, so I'm going to now say, let's do this like n1 equals input, enter first number. And I'm going to do a strip here, just because, truth be told, I almost always use strip after I'm using input, just because, like, why not? I lose nothing in the bargain. And then I can say here, n2 equals input, enter second number. And then I can say here something like this. If n1 is digit, let's do this. If n1 is digit and n2 is digit, then I can say here print, well, I can then say something like this. I can say n1 equals int of n1, and n2 equals int of n2. And I can say here print, let's say n1 plus n2 equals n1 plus n2. And notice, here the plus is in the string. It's between the curly braces. Here the plus is inside of the curly braces. So the expression here will be n1. Expression here will be n2. Expression here will be n1 plus n2. So that's the addition of both of them. But then I can say here, elif n1 is digit. I'm actually going to make this a little easier to read. Not n1 is digit. I can say here, actually, I don't want to do this. Oh, then we can do this. Oh, this is getting kind of ugly and gross. Fine. So I can say here, if not n1 is digit. I can say here, print, right, error. N1 is not an integer. This is not the most beautiful way to write this, but fine. If not, N2 is digit. And we'll say here print, 2 is not an integer. And so now if I run this, so I'm going to say like 10 and 5. Oops. Wait. What? Oh, but I turn them into integers. Yikesies. Okay, fine. So you know what? Let's do this. Oh, for crying out loud. Just to explain to you the problem that I had here, I turned n1 and n2 into integers, and isDigit is a string method, right? So that was a bad thing to do. So I'm going to say here something like this. We'll say here else. Fine. That's probably a better way to do this anyway. Yeah. Thank you. Okay. Not the most beautiful in the world, but we'll deal. 10 and 5 is 15. Very good. But if I now say 10 and 5, say 5 is not an integer. And if I say here, blah, 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 and blah, 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 right? And it'll find both of these. Now, our code is starting to get longer and more complex and more sophisticated. And that's good. And that's okay. As long as it's readable, as long as we can understand the logic of what's going on. And even more importantly, as long as other people can read and understand what's going on, right? Because at the end of the day, the hard part, I've said this before, the hard part of programming is not the programming itself. I know that's hard to believe, that's true. But rather the maintenance of the code, the debugging of the code, that 6 months, a year later, you're going to discover, oh, wait, we didn't handle such and such a corner case. And then you've got to go in and debug it, and heaven help you if you don't understand. Any other questions or comments about what I did here? And I'll show you one or two other methods before we finish up. Okay. And if you have questions, it's okay. You can like put them in the chat and we'll see them in a moment. So last week, and even earlier today, we saw we can use in to determine if one string is in another. So I can say here's A in A, B, C, D, E. So far, so good. But if I want to know where one string is in another, how do I do that? Well, for that, I use a method. What method? The index method. Use the index method. So if I say here abcde dot index of b, it returns 1. What does that mean? It means that it found b there at index 1, 0, 1. Right? In the same way, if I say here index of d, what's it going to say for d? It's going to say 3, 0, 1, 2, 3. Remember that we're counting, right? If I say here 0, 1, 2, 3, 4. Those are the indexes there. Now, this might lead you to say, wait, what if there's more than one? So I say here, and if I say s equals abcde, 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 now I say s dot index of d. It will always do from the left side. So it finds the index, the first index from the left side. Well, what if I want from the right side? If you want from the right side, use .r_index, s.r_index of d. And then it looks from the right side rather than the left side. And of course, if I say now s of 13 should return d, and indeed it does. So this is how you can search for things inside of a string, not just to find out if it's there or not, but to find out where it's there. But, what if I say s.index of exclamation point, right? Is, where is it? And of course, it's nowhere to be found. And we're going to get an error. We're going to get an exception. It even says substring not found. This is a problem for us, but we haven't talked about how to trap exceptions and errors and so forth. So it's a little bit of an issue. A sneaky way around it, this problem is to use the find method. So if I say s.index of d, right, if we find the d, we get the same result as index. Sure enough, it'll say 3. But s.index of exclamation point, if we don't find it, then we get back -1. Oops, not index. I want to use find. There we go. Sorry about that. Come back. -1. So that's an easier way to deal with things. So I could say here like index equals s.find of exclamation point, and I can say if index equals -1, print did not find in S. So, otherwise I can say, else print found exclamation point in S at index. Right, so if I run this sort of thing here, but now if I look for find of, let's say C, oh, well, now it's going to say C. Right, so that's going to work pretty well. So we've talked about a whole bunch of methods. We talked about the strip, and we talked about lower and upper and capitalize and even swap case. And we talked about what else? Replace. And we talked about index and find. That's a lot of methods. It's not, I'm sure I've missed one or two. That's not all the methods that there are. And again, part of the deal is like when you encounter a new data structure is finding out what methods does it support and how does this method work and where would I use it? And over time, you'll add and add and add to your vocabulary and figure out like what these methods are and how you can use them in various ways. Questions, comments, thoughts about any of this? All right. Oh, if a character is found at left, right, and middle, then you're stuck. I mean, you can actually, let me just check. Help on stir index. I think you can actually say where to start. Yeah, so you can actually like tell the index not just what to look for, but you can optionally say where to start and where to end. So what you could do, Marv, is you could say, okay, I found the first one, find the second one, like at an index above that. And next time we're going to talk about loops, so we can see even, I'll try to remember to talk about this, like how to sort of move forward through it. But you might just have like no luck. You might need to actually go through the entire string to find out where something is. And Dory asks, why use index and not find? That is a fantastic question. I'm going to ask an even better question, which is why the heck do we have both index and find in Python? Why would we need two methods that do the same thing on success and different things on failure? And the answer is history. That's the answer to a lot of things in the world, right? And basically there were enough people who were using each of them that they kept them around. I know that it seems weird that we would prefer to get an error, an exception as they're known, rather than getting -1 back. Exceptions are actually a good thing. Getting an error message that can't be confused with a value is a good thing. Think of it. Let's say I get I run s.find and I get back the index. And I don't run this check. In fact, here, I'm going to do this here. I'm just going to run this here. All right. So I'm going to say here, index equals s_find. And I'm just going to say like, just make sure, well, s equals abcd, abcd, abcd. All right. So I'm just going to say, I found, right? So I'm going to say here, print, this is a print s at index. So far, so good, right? So I'm going to say s equals abcd. It's going to find c. It's going to get the index, and we're going to print it out. Sure enough, fantastic. What if I look for something that's not there? Well, if I look for question mark, it's going to show me D. D, what the heck? Because here, s.find returned what? -1. And remember that indexes, negative indexes, count from the right. So it said, oh, -1, you should do this. And this is dangerous. This is a problem. It means basically that I can get a result back from s.find that I then have to check. By contrast, if I'm using exceptions, if I have that error there, then I'm forced to handle it. I can't mix up that error message with actual data. And that's one of the most compelling reasons to use exceptions. Right now, we don't have the tools to actually trap those exceptions. So I'm telling you about find, but in like real code, I would argue that index is actually better than find, rather than inferior as it might seem. Okay. Other questions or comments anyone might have? Okay. Well, in your line of work, you use index because the clause is known. Okay. Maybe I'm just like getting old in that I get worried about these things, or I'm skeptical or worried that users are going to enter all sorts of crazy stuff. But it's good to be optimistic. All right. I think we are going to stop here for today. So first of all, thanks to everyone for joining me. I am having such a blast with this course. Oh, what would be the big O for both? Goodness gracious, I'm guessing both are O of n, meaning that they take, it's linear time. So the longer the string, the longer it takes to get there. All right, thanks everyone. I will see you next week. I'm gonna put this up hopefully within the next hour. If not, then tomorrow night, but should be up in the next hour or so. I'll put some homework questions in the forum. Don't be shy, post the forum. And I will see you guys in a week and online in the forum until then. Have a fantastic weekend. Thanks again for joining me.